Hey guys, it's Tiffany. Today I'm going to show you how to solve equations in two variables. Solving equations with two variables using the elimination method. Steps to follow when solving equations with two variables. First, you want to decide which term you will eliminate. After that, use the distributive property to change the appearance of the equations. Next, add the terms in the equations together. Finally, you're going to solve for the remaining variable. Example number 1. Let's say I have the equations x plus y equals 5 and 2x plus 3y equals 13. First, I'm going to make sure my equations are in standard form, and they are. Now, I prefer that my x values and y values are a little more on top of each other than these two are, so I'm going to just rewrite them so it's even more clear. So I have x plus y equals 5, and then I have 2x plus 3y equals 13. My next step said I'm going to use the distributive property to change the appearance of my equations. The reason I'm going to do this is because I'm looking for terms that I can cancel out, okay? I'm either going to say, hey, let me look at these x's over here and get rid of those, or I'm going to say, hey, let me look at my y's and get rid of those, okay? I'm trying to eliminate some variable. Typically, when you're eliminating a variable, you want to take the coefficient in front of the variable. So let's say I choose to eliminate my x's this first time. I could say, well, what's my coefficient in front of this x? There's nothing here, so that means there's a 1. What's my coefficient in front of this x? 2, okay? Typically, a person might multiply the opposite equation by the coefficient of the other equation. That sounded a little wordy, but let me make sure you understand what I'm saying. Basically, switch these two numbers, okay? So you have a 2 here and you have a 1 here, so switch their positions. Put the 2 up top, put the 1 at the bottom, okay? Now, the only thing about this is we're gonna need one of these terms to end up being negative. So I'm just gonna choose one of my two terms over here that I just switched positions for. I'm gonna make one of them negative. So I'm gonna choose to make my 1 negative, okay? The reason I'm making the 1 negative is because I think it's gonna give me easier math. If I had to deal with a -2, that's a little bit more work for me. So a -1 is probably gonna be easier. That's why I'm choosing the 1, but you could choose the 2 and it's gonna work just the same. Now I'm gonna use the distributive property with these numbers. I'm gonna distribute my 2 to my first term. Then I'm gonna distribute it over here to my second term. And then I'm gonna distribute it all the way over here to the 5, okay? And I'm gonna rewrite a new equation. The equation is gonna look different, but it has the same value to it, okay? So I have 2 times 1x, which gives me 2x. I'm gonna leave a little space and I'm actually gonna write it way over here. And then 2 times my positive y, and that gives me a positive 2y. And then I have my 2 here again times my 5. And so that leaves me with equals 10. Now I'm going to do the same thing, but with my -1 on the bottom, okay? I'm going to still distribute, but I'm going to have my arrows going underneath. Same thing though, doesn't matter. So this results in -1 times 2x. So that's going to give me -2x. And then I have -1 times 3y, and that gives me a -3y. And then it's -1 times 13, and that gives me -13. I'm going to draw a line here because if you remember, the next step said that I'm going to add both of my equations. I have 2x minus 2x. That ends up being 0. This term, the x terms are eliminated. That is where this process gets its name from. This is the elimination method because you are getting rid of stuff when you do this, okay? It helps you have less math to do. If you were to solve these problems using the substitution method, you would have a lot of work to do. You have a lot of plugging in, okay? And I actually have a video solving these exact same problems using the substitution method. So go watch that video if you want some help with that, okay? The exact same numbers. I solve them using a different method. So now I'm gonna add my y terms right here. This is where I am. I have 2y, and I'm gonna take away 3y. Well, that leaves me with -1y. And if you remember, you don't have to put that one coefficient, so you can just write a -y. And that equals, let's see, 10 minus 13 gives me -3. So I've explained this in other videos, but whenever you have a negative variable and it equals a negative number, you can just drop your negative signs on both sides. And this is the same thing as y equals 3. That is because this is like having the problem negative y equals -3. And you remember that there is a one coefficient here. It's like saying, hey, I'm going to divide by -1, divide by -1 on both sides, and you're left with y equals 3. Okay, so basically I just know that's going to end up being positive on both sides. I know that it works this way, so I'm not going to take the time to do it. I'm just kind of like giving myself a shortcut. Now I have my answer for y, but I don't have my answer for x. So what I'm going to do is this exact same process, except I'm going to eliminate my y values so that I'm left with my x variable and I can get that answer, okay? So I'm going to move my y equals 3 up to the top of the screen and start the elimination process again, but I will be eliminating my y variables this time. All right, so now I'm going to take the exact same steps, except I'm going to do it in reverse. I'm going to put things together so that I can eliminate my y terms. The last time I eliminated my x's, okay? So I have x plus y equals 5. Then I have 2x plus 3y equals 13. Okay. Last time I switched the coefficients for my x values. This time I'm going to switch the coefficients of my y values, okay? So draw my line here, kind of just showing some separation. There is a 1 here, and I'm going to switch these two. I'm going to put a 3 here, and I'm going to put a 1 down here, okay? If you remember, one of them has to be negative. I'm going to make my 1 negative because it'll probably make my math a little bit easier. Now I'm going to distribute 3 times my x, and of course there's a coefficient of 1 here. So that means I have 3x. Now I'm going to distribute again. 3 times my 1y leaves me with 3y. Then I'm going to distribute again. 3 times my 5 equals 15. Now I'm going to distribute, but for my bottom equation. -1 times 2x is -2x. Then -1 times 3y is -3y. Then -1 times 13 is -13. Now I can add my two equations, okay? I'm going to get rid of my y variables now because the coefficients are opposites. I didn't explain this exactly in the last one, but because we have a positive 3y and a negative 3y, they counteract each other basically, and you end up with 0. That is the point of switching the coefficients. When you switch the coefficients and multiply across that way, you're going to end up with numbers that have the same coefficient except the signs are different, and that automatically ends up resulting in a 0. So these are eliminated, okay? Now I'm going to add the other terms in our problem. We have 3x, and we're going to take away 2x, so I'm left with 1x, so I can just write x. X equals whatever 15 minus 13 is, and that's 2. So now I have my two terms. I have y equals 3, and I have x equals 2, okay? So now, if I wanted to, I could check to make sure my answers are correct. The x equals 2 and the y equals 3. And the way I would do that is by plugging those values back into the original problem. Now I'm going to do that in a different color to make sure you understand that I'm no longer solving the problem. I'm actually checking to see if my answer is right. Okay, so now I'm going to rewrite my two equations. Start with the top one, x plus y equals 5. And now I'm going to plug in the values that I just calculated each of these variables to equal. So instead of x, I'm going to write 2. And then instead of y, I'm going to write 3. And these should be correct. And it is, because 2 plus 3 is 5. So 5 equals 5. Okay, so that means I did it correctly. I solved that one correctly. Now I'm going to do the same thing, but with the second equation. Okay, so I have 2x plus 3y equals 13. Instead of writing x right here, this time I'm going to write a 2. Instead of y right here, I'm going to write 3 equals 13. 2 times 2 is 4. 3 times 3 is 9. And 13 is over here. 4 plus 9 is 13. So because 13 does equal 13, that means I got the right answer, okay? If I were to plug in numbers and I got something at the end like 7 equals 13, which is completely not true, then that means I did something wrong somewhere. My answer is not correct, okay? Or it could have even been that when you were checking, you did something wrong, but somewhere along the line, something's not right. It should end up equaling itself at the end, okay? That's how you know you did it correctly. Let's take a look at another example. Example number 2. I have 6x plus 3y equals 30 and 2x plus 5y equals 26. Well, I like these two equations because they are already nicely stacked. Our other ones, because like the top equation didn't have any coefficients on like the two variables, our numbers weren't perfectly stacked. So I'm not going to rewrite them this time. These are nice, okay? I am going to switch my coefficients so that I end up with numbers that cancel out nicely, okay? So I'm kind of blocking it off to make sure I clarify what was originally there and what I'm writing. Now, of course, this is typed and then mine is going to be in handwriting, so it's going to be obvious. But if this were on like your piece of paper, it might not be so obvious. So like blocking it off would be a good step to take. So let's say I eliminate my x's first. So I could just like reverse these coefficients. I could put a 2 up here and I can put a 6 up here, okay? One of them needs to be negative. I usually go with the smaller number, okay? So I'm going to make my 2 negative. Now I'm going to distribute across, okay? Negative 2 is going to go to all of those. So negative 2 times 6 is going to be negative 12x. And then negative 2 times 3y is going to be negative 6y. And then negative 2 times 30 is going to be negative 60. Now I'm going to do the same thing, but I'm going to distribute everything for my lower equation. So 6 times 2x is going to be 12x, and that one's positive. So then 6 times 5y is going to be 30y. And then 6 times 26 is 156. Now I'm going to add my two equations, okay? Well, when I first start out, I can see that these are going to cancel each other out. The x terms, I have a negative 12x and I have a positive 12x. These are eliminated. That's the purpose of this procedure. It eliminates different chunks of our problem and it makes it easier for us, okay? So we have less to do. Now I'm going to add here. I have negative 6y and I'm going to add 30y. That leaves me with positive 24y. And then that equals 96. Now I'm going to divide by 24 on both sides. And I get y equals 4. Okay. Now I'm going to do the exact same steps, but I'm going to switch my y coefficients so that I can eliminate my y terms and calculate the value for my x. So I'm going to switch my y coefficients. I have a 3 right here and I have a 5 right here. So I'm going to put 5 up top and 3 on the bottom. I'm going to make my 3 negative. Now I do want to point out something. If one of your signs here was already negative, then you wouldn't have to make one of them negative on the outside, because when you go to multiply, you're going to end up with it being negative already. So adding a negative would actually not allow things to cancel. Okay, so that's something you do want to take note of. You want to make sure that the problems result in one positive term and one negative term. Okay, so now I'm going to distribute 5 times 6x, 5 times 3y, and 5 times 30. Okay, so 5 times 6x is 30x plus 15y equals 150. Okay, now I'm going to do the same thing, but I'm distributing on the bottom all the way across. Negative 3 times 2x is negative 6x minus 15y equals minus 78. Now I can eliminate. A positive 15y minus 15y goes away. Now I can add my other terms. 30x minus 6x gives me 24x, and that equals 72. Divide by 24, divide by 24, x equals 3. So now I have the value of my two variables. X equals 3 and y equals 4, okay? Those are down here. What can I do to check? I can plug these values back in and make sure I end up with true statements. I'm going to do that right here. I have 6x plus 3y equals 30. I have 6. What's my value for x? My x value is 3. What's my value for y? Y is 4, and that equals 30. 6 times 3 is 18. 3 plus 4 is 12, and that equals 30. 18 plus 12 is 30. So 30 does equal 30. We solved that one correctly. Now I'm going to do the same thing, but with my second equation. I have 2x plus 5y equals 26. I'm not going to write x again. I'm going to write 3 because that's what I calculated x to equal. I'm not going to write y again. I'm going to write 4 because that's what I calculated that to equal. 2 times 3 is 6. 5 times 4 is 20. And that equals 26. 6 plus 20 is 26. So 26 does equal 26. Okay. If I were to get something different there, like 10 equals 26, then I know something's wrong somewhere. Okay. Now let's take a look at a word problem. Example number 3. 5 shirts and 3 blazers cost $165. From the same shop, 4 blazers and 6 shirts cost $212. Find the selling price of blazers and shirts. Okay, first I need to take the information out of this word problem and I need to make it into an equation, okay? I'm going to start by changing my 5 that's written out in words and write it as a number. I like to see all my numerical values as an actual number, okay? So I have 5 shirts and 3 blazers, and they cost $165, okay? That is about as straightforward and clearly written in words as you're gonna get when you're taking something from a word problem and putting it into an equation, okay? I'm gonna rewrite this with some words, but less words, and you're gonna see how I can say that, okay? This is saying I have 5 shirts and 3 blazers. If you were to think in math terms, what calculation does that sound like? And what calculation does that sound like? To me, that sounds like addition, okay? I have 5 shirts and 3 blazers, or plus 3 blazers, right? So 3 blazers, I'm gonna write that as 3 blazers, okay? They cost $165. What does cost mean? Cost means equal, okay? They equal $165. Now, I'm gonna take a few more words out of this, okay? I'm gonna say, instead of shirts, how about I just write S? So this becomes 5S plus 3B, and that equals 165, okay? It looks a lot more like an equation now. Now, let's keep reading. We only did the first sentence. It says, from the same shop, 4 blazers and 6 shirts cost $212, okay? So we could do that too. 4 blazers and, or plus 6 shirts equals $212, okay? So again, that equation basically just came straight from this sentence. 4 blazers, okay, that's here. And plus sign, okay, got that. 6 shirts, that's here. Costs or equals, okay, right? Doesn't that make sense? 212, okay, came straight from there. Now I'm gonna do the same thing as I did with the first equation. I'm gonna take more of the words out. So it's just 4B plus 6S equals 212, okay? So 4 blazers plus 6 shirts equals $212, okay? It doesn't look that bad when I do it, when I break it down like that, right? Now the question asks, find the selling price of blazers and shirts. So we want to figure out how much is a shirt, how much is a blazer, okay? So now what I'm going to do is I'm going to clear everything off my screen and rewrite this in a way that doesn't look quite so cluttered. Okay, so here are my 2 equations, okay? So now I'm ready to do the elimination method, and I can see that my terms and my variables aren't exactly stacked in the same order as each other, okay? I have my S variable first on this problem, and then my B variable, and on my second equation, I have my B variable first and then my S. That's not gonna work for elimination. They need to be directly on top of each other. So I'm just gonna take my second equation and switch the 2 terms over here. So it's gonna be 5S plus 3B equals 165. And then I'm gonna write my 6S first plus 4B equals 212, okay? Now, I'm gonna give myself some boundaries, and I'm going to switch my coefficients. So 6 up here and 5 up here. I'm gonna make one of them negative. I'm gonna make the 5 negative, okay? Now I just distribute to each term like I've done for all the past problems. 6 times 5 is 30. So that's gonna be, and I'm gonna go ahead and put my answer over here, 30S. Now I have 6 times 3B. So that's 18B. And that equals 6 times 165. And that gives me 990. Now I'm gonna do the exact same thing, except I'm gonna distribute with my lower equation. So negative 5 times the 6x, then times the 4b, then times the 212. So negative 5 times 6 is negative 30s. So then my negative 5 times 4b is going to be negative 20b. And then my negative 5 times 212 is going to be negative 1060. Now I can add my 2 terms, and my 30s, my 30s and my negative 30s get eliminated. They go away. Now I'm going to work with the 18, and I have 18b minus 20b, and that leaves me with negative 2b. Then my 990 minus 1060 leaves me with negative 70. I'm going to divide both sides by -2. And B equals 35. Now I'm going to do the same thing, but I'm going to switch my B coefficients. So I'm going to start off by rewriting my equations, and I'm going to remember to switch the two terms on the bottom equation so that I can eliminate easily. So I have 5s plus 3b equals 165. Then I have the 6s plus 4b, and that equals 212. Okay. Now I'm going to eliminate, but I'm going to be switching my b coefficients. So I'm going to put a 4 up here and a 3 down here. I'm going to make the 3 negative. Distribute over here, and over here. Okay, so 4 times 5 is 20s plus 12b, and that equals 660. Now it's time for me to distribute everything for my bottom equation. -3 times 6 is going to be -18s. -3 times 4b gives me a -12b, and that equals 636. Now I can eliminate my b values because a +12b is eliminated by a -12b. They turn into 0. Now I have 20 s's, and I want to take away 18 s's, and I'm left with 2 s's, and that equals 24. So I divide by 2 on both sides, and s equals 12, or shirts equals 12. So what can I do to check my answer? I could plug these in to make sure that I get true statements, just like I've done on the other problems, okay? And I want to clarify that these amounts are dollar amounts. B for blazers, that's the price of the blazers, and S for shirts, that's the price of the shirt. So the question asks here at the end, find the selling price of blazers and shirts, okay? So the price for the blazers are $35, and the price for the shirts are $12. If you plug them in, you realize that these will give you equal values on both sides of your equal sign. So that means it is the correct answer. Let's take a look at example number 4. Example number 4. It says Sarah spent $168 on plates and bowls for her restaurant. The price of a plate is $5, while the price of a bowl is $4. If she bought 12 more plates than bowls, how many plates and bowls did she buy? Well, first I need to pull the information out of this word problem to set up my equation, okay? So it says the price of a plate is $5. So that tells me that I'm going to end up with a 5p, okay? While the price of a bowl is $4. So that tells me that I'm going to end up with a 4b, okay? And it also tells me at the very beginning that Sarah spent $168 on plates and bowls. So that tells me if I add the plate price plus the bowl price, that should equal $168, okay? That's where I'm going to get my first equation from. Now, this last sentence from this equation that starts here, it says, if she bought 12 more plates than bowls, how many plates and bowls did she buy? Well, that tells me that my next problem needs to be not about dollar amounts. See, these were dollar amounts. The 168, that was her total price. The 4, that was the price per bowl. And the 5, that was the price per plate. So this particular equation basically talks about your price, how much you're paying. My next equation is going to talk about quantity. If she bought 12 more plates than bowls, how many plates and bowls did she buy? Well, that tells me that the amount of bowls that she bought was the smaller number. And so I could say the amount of bowls she bought plus the number 12 should equal the amount of plates that she bought, okay? So they didn't give us a whole lot for that one. I just had to kind of like use my own common sense. It says if she bought 12 more plates than bowls. So here's my bowls. And you had to buy 12 more. okay? This is the number of bowls, I should clarify too. The number of bowls plus 12 more to that number. That's gonna equal how many plates she bought, okay? So the question asks, how many plates and bowls did she buy? So basically, what do B and P equal, okay? So when I solve this one, I'm gonna leave it as my P and B, just like I did on the last one. But then at the very end, I'm gonna change it to X and Y, because sometimes you have to graph these. And if you're gonna graph, you would rather have it as an X and a Y variable, not as a B and a P, okay? So now I'm gonna take these things and I'm gonna stack them directly on top of each other to make sure everything's in standard form, okay? Right now, this equation is not in standard form, okay? So I'm gonna rearrange these terms so that they are in standard form, so then I can start my elimination method, okay? So I'm gonna put the 12 over on the right side of the equal sign, so I'm left with B equals P minus 12, and then minus P, okay? So B minus P equals negative 12, okay? Basically, I just moved my terms around using order of operations, okay? So these are gonna be my two equations. This one here, and this one here. I shouldn't try to do elimination method with this equation because it's not in the right format. So now I have 5P plus 4B equals 168. And I'm looking at this right now, and my B is written first and then my P. And if you remember on the last example, I had to switch those two things to make sure they were stacked on top of each other. So I'm actually gonna write my P value first, and I can't just straight up switch them. That P is gonna be like a negative P because there's a minus sign in front of it, and then it's gonna be plus B, okay? And that equals negative 12, okay? Now I'm gonna use the elimination method here, okay? First, let's eliminate my P's first. Now, one thing that's nice about this one is there's already a negative number with this P, so I don't need to make one of my numbers out here to the side negative. I just need to switch in my coefficients. I can have a 1 up here and a 5 here, okay? When I distribute, I'm already gonna end up with a negative coefficient here, so those are gonna cancel out. So one thing I like about also having a 1 as a coefficient is I don't really have to do any math on the top, okay? This basically is already done for me because remember, anything times 1 is 1. So I don't have to distribute the 1. There's like no point. So I'm just gonna rewrite this one. 5P plus 4B equals 168. Now I'm gonna multiply my 5 across. 5 times negative P is negative 5P. And then it's a plus 5B. And that's gonna equal negative 60. Now I can add. These eliminate. Now I have 4B plus 5B, and that equals 9B. And then I'm left with 108 right here. Divide by 9, divide by 9. B equals 12. Now, because I'm running out of space, I'm going to erase the left half of my screen so I can continue with my elimination method. So now I'm gonna start back with my two original equations. I have 5P plus 4B equals 168. And then I have the negative P plus B equals negative 12, okay? I'm gonna switch my B coefficients, and I have a 1 here, and I have a 4 here. I'm gonna make my 1 the negative this time, okay? This time I do have to carry a negative over because considering my B terms, neither of them have a negative sign in front of them, so I do need to bring a negative sign this time. The last time over here on this side, I had a negative sign down here in front of my P, so I didn't have to bring any negatives anywhere because I knew they were going to cancel out. So that's something you have to keep in mind. You do sometimes need to make it negative. The number you're distributing across will need to be negative, but sometimes it won't need to be negative if your sign in front of the term is already negative. So one thing that's nice about distributing a negative 1 is basically you just rewrite the problem, but the signs of everything becomes the opposite. So this is going to be a negative 5P minus 4B equals negative 168. Now I'm going to distribute my 4, and I have a negative 4P plus 4B equals negative 48. Now, These eliminate. So negative 5p minus 4p equals negative 9p. And that equals negative 216. So then you divide by negative 9 on both sides, and you get p equals 24. Okay. Now, if you were to plug in these two terms, you would get values that equal each other on both sides of the equal sign. Okay. So p equals 24 and b equals 12. And this is in reference to the plates and the bowls. So remember, the question asks, how many, here it is, the last line, how many plates and bowls did she buy? So this isn't talking about a dollar amount. It's not the price. Remember, they already told us the price. They said the plate is $5, the bowls are $4. So the plates, the amount that she bought 24. And then as far as bowls go, she bought 12. Okay? Now, let's take a recap. When solving equations with two variables, the first thing you want to do is decide which term you're going to eliminate. After that, use the distributive property to change the appearance of the equations. Next, add the terms in the equations together. Finally, solve for the remaining variable. Now you try. Comment with the two numbers below. 4 tires and 3 windshield wipers cost $572. From the same shop, 2 tires and 2 windshield wipers cost $298. Find the selling price of tires and windshield wipers. After you figure this out, I want you to comment in the comment section below. Then head over to my website and click video answers to see if your answer is correct. SuperEasyMath.com. Don't forget to like and subscribe. Did you find this video helpful? Well, you can get more help from me on my website, SuperEasyMath.com. While you're there, you can pick up my top 5 math tips to make learning math easy.